one is uncontrolled, another one is uncontrolled. So we are using diode, okay, that is uncontrolled, and it's a halfway, means only one cycle you are make it in alternating signal to alternating voltage to the rectified one, okay, for only one cycle. Okay. So here what we are going to observe, we are changing the parameter value. Okay, what type of parameter value? Load parameter value. There are different types of load already there. Okay, so first we are using R load. So after doing the simulation, what we will do? We will change the parameter of R. Okay, so I have discussed in this regard. Okay, already I have discussed. I will share the link. Okay, you please listen it. How am I telling? I will share you the 2-3 links. Okay, about it, about the simulation one. Some link I will provide you how the simulation is going on, that you can see. Another thing is that what you need to perform. Okay, I am discussing here. Again, I am sharing the link so you can understand what kinds of parameter you need to change. Okay, that same thing I am discussing here. And next one is that how you have to prepare the observation table. Okay, for changing with the parameter value, what will be the significance component will be there in the column. I'll discuss here. Still, I will share you the link so for your reference. Okay, so you can prepare based on that. Okay. So in this case, what we can see, we are changing the first is we are changing the value of R. Okay, so we are considering only resistive load. So if we are able to change the value of R, how much parameter value we are going to change? Normally, you know that from the circuit diagram. So you know that what will be the structure of the report. Okay, first you need to write the objective, then theory. The very brief theory is given here, so it is not justified. It is only the left alignment is given, so you have to prepare in a justified manner. You know that report is very important thing, how nicely you have prepared. How, not like nicely means a presentation is very good, it's not like that. Means you have to prepare the report, the contents also be very enriched. Okay, enriched content should be there. So those are giving best effort for their report. Definitely they will be evaluated. They are higher grade. Okay, and then the comparatively, you know, the relative marking is there, relative grading is there. So those are performing best. They will get the best mark, best grade, and according to the decreasing the performance, so the grade may be changed. Okay, with that other person. So report is very important thing. How to present yourself, that is very important factors for this marks. Okay, so you know that for the marks we are having several components. Every day MCQ test will be there. After discussions of this simulation, there one small MCQ test will be there. And after next class means next simulation lab will be experiment number 2. Okay, so only event date of experiment number. Okay, that day one viva will be conducted. Okay, suppose the next viva will be there, experiment date of experiment number 2 means next week. Okay, and then next viva will be there, experiment number 4 means next week. After that another week, after that another week. Okay, fourth experiment, date of fourth experiment, like that the viva will be conducted. Okay, and your marks content, some portions will be there MCQ test. Okay, some of the viva, then most important part is your performance. Okay, those are attending the class, definitely they will get the good marks. Those are not attending the class, every day I am taking the attendance as well as the cross checking with their online, cross checking their logging time. Okay, so when they are logging in that meeting, okay, every day the meeting will be started around 1:30, in between 1:15 to 1:30, like today, so around 1:30. Okay, so then some marks will be there for your laboratory report, and finally we will take one exam. Okay, based on that all the marks will be separated, okay, and segregated, so combined marks will be given the entire grade. So throughout the class you have to perform well. That's the simple one. Okay, and you know that and you know all the things that those are giving their best performance, they will get the good marks. So there will be no doubt on it. Okay, so you are in almost 8 semester, means almost verge of completion of your degree. So I think you can do your, you know, all those method. Okay. So theory portion is very important, but here the brief theory is there. Okay, I have mentioned only the brief theory. Okay, so just for your reference, but when you will prepare your report, the theory will be very good in manner. Okay, so it should be well documented. Okay, then figure 1, figure 2, figure numbers also be important. Then procedures are there. Here you can see the simulation. We can see the simulations are starting. Okay, so what is your input voltage? Everything is given: 100 volt, RMS, 50 hertz. Okay, so this is measurement. Okay, so RMS value you are getting over here. Okay. And you know that which diode we are using. So based on that, we are using Moore diode. Okay, Moore 420. So 200 volt, 4 ampere maximum. So 100 volt is the RMS. So we are considering 200 volt. Okay, and that you can see the ammeter is there and load resistance. So for this study, what are the parameters values are there for input voltage configurations? Everything is given. Okay, so input voltage parameter, then transient analysis configurations, that what are the parameters are given. You can see from here, everything is given over here. So, okay, then which parameters are there, so based on that we will plot them. Okay, I, V, both the case, input voltage, output voltage, and current. Okay, output current. So here you can see that input voltage waveform, that 100 volt RMS is there. So maximum value, how much it is coming. Okay, so you are getting over here that sinusoidal waveform, how, what are the values directly you can get from this figure. Okay, then the load voltage, how will you look like that load voltage, changes of the voltage. Sorry, one, you know, it's a half wave rectified, so only first half is rectified, second one is second half cycle is not rectified. Okay, so it's look like that. Then input current, so voltage is there, so resistance, load resistance you are given, so divided by there, so you will get some current. Okay, current pattern you can see over here. Then we are using RL load. This is only for R load. So after this one, what you need to do, you have to prepare a table, observation table. Okay, so what was that observation table? That observation table having some the observation table having some column. Okay, what are the different types of column? Okay, all of you please note it down to your copy. Okay, so the column will be, first column is the serial number. Okay, second column is your second column is your load resistance. Okay, so you are changing the load resistance, and you need to see what output voltage is changing. Okay, is it same or is it changing? So our main motivation is this lab to changing the load pattern. Okay, to changing the load pattern, how the load voltage is affected. Okay, how the how the system behaves with changing the load value. That is our agenda. Rest of the thing is very basic one. So anybody can do it, from first year student, anybody can do the simulation. But our target is that how the system is behaving with the changing of the values. Okay. So first column is the serial number. So we have to take the 10 sample. Okay. Why 10 sample? I am telling, I am coming that point. So 10 sample we need to see. Here you can see that load resistance is 100 ohm. So we can 100 ohm maybe the middle one, 10 sample is there. So fifth one is the 100 ohm. So another 4 sample before 100 ohm will be there. Okay, and another 5 sample will be there after 100 ohm. Okay, so you can vary the 10% like that. 100 ohm, before that one is maybe 75 ohm. So another is 50 ohm, then 25 ohm, 1 ohm. Okay, so 1 ohm, 25 ohm, 50, 75, 100, then 125. Okay, then 125 now you can make it double. So 200, 400, 600, and 800,000. So different sample you can take. And what you need to see, you have to see your So what you need to see, you have to see that your average output voltage. Okay, average output voltage. How is it changing? Okay, is it fixed or is it changing? That you need to see. So your second column is load resistance. Then third column is what? Third column is your power input. Okay, so input power. So what power you are given? So RMS power. Okay, P in RMS. Okay, P in RMS, you can easily get it from there. P in RMS. Then fourth column is that what? Fourth column is your output voltage, then output current. Okay, fourth column is your output voltage, then output current. Okay, you have to measure it. From where you will get the measurement? Here you can see. Okay, so that you can see from here this multimeter or digital voltmeter, digital ammeter. Okay, from here you can see that value RMS, average value of your output voltage, output current, and output voltage. Next, you have to get that output power, that average output power. So whatever power you have given and whatever power you have get over here. Okay, then efficiency. Okay. Oh, another thing I have forgotten. Okay. Now, what is another thing that average power, average voltage you have measured? So some formula is there. Okay. So half wave rectification, you know that if you open that power electronics book, you will get some formula. Okay. What is that? Mathematical expressions is there. Expressions are there for average voltage, formula of average voltage. Okay. So Vm by 2 pi cos alpha, like that, different formulas are there based on that half wave, full wave, okay, whatever say voltage is there, based on that it is there. So you get that value. Okay, you can implement that formula over there. Okay, you can implement that formula. So when you are preparing the theory, that formula is already there. Okay, so you put the formula, now you have that value, Vm value is there. Okay, so alpha value, in this case alpha equals to 0, so there is no firing angle. Okay, so alpha equals to 0. So put those value, and what calculated output voltage, calculated average output voltage is coming, you need to calculate it from that given data. Data is already there with you. Okay, and what measured values are there? Now you are changing the load resistance. So is it changing? So you have to check it. Okay, you have to check it. Then measure error. Okay, so error calculation. So reference minus actual by actual. Reference is your what is calculated value is coming. That is your reference minus actual. So what you have measured from your voltmeter. Okay, that is your actual, and whole divided by actual one. Okay, so from where you will get some error. Okay, and then efficiency calculations. Okay, so P out is there. Okay, you can calculate the P out average. Okay, and P in RM is already there. That input is your AC. So what is your efficiency? That you can also calculate. Okay, so you can prepare the observation table that with having 10 sample. Okay, 10 sample of changing resistance. Okay, and that waveform is there. Na? So here you can see the output voltage waveform. Okay, so output voltage waveform is there. So load voltage waveform, that means output voltage waveform is there. So one column you crop it. Okay, so with the changing of load resistance, different output voltage you will get. So 10 sample will be there, means from where you will get that average value. So you have to do the simulation, you have to perform the simulation. When you will perform the simulation, you make that picture. Okay, so crop that one. Okay, and paste one column. Okay, paste one column of your table. Okay, so what you can see, so you can also visualize what will be the load resistance waveform. Okay, so sorry, what is the load voltage waveform? So now you are taking the 10 samples, so you will prepare a big observation table for changing of load resistance. So you make only this page in landscape mode, so you can easily realize. Okay, so our agenda for this simulation, so basically for when we are performing the experimental, so all the time with the changes of that parameter regime and load parameters, it's not possible. Okay, basically that amount of resistance all the time is not available in the lab. So in simulation, we will do the same thing and try to understand the system behavior, try to understand the system performance. That is our prime target. Okay, rest of the portion is second year, first year level job. But what you will do, that observation table, I am big observation table I am asking about, I am discussing here, that is your main contributions. Okay, how you are preparing them. Okay, so it will not take a lot of time. Okay, every day if you give some amount of time, so you can get it. So that table you need to prepare. Okay, so like resistive load here you are using. So in case of RL load, you do the same study for variation of that variation of the L. Okay, R you can also vary, but your report will be so big, so that time is not in your hand, so you can only change the inductor value. So you can see very less amount of inductor. So ringing effect will be more. What is the ringing effect? So if we go for that waveform, you can see. So it is your RL. Okay, so voltage waveform, you can see some negative voltage is coming. Okay, so here you can see some negative voltage is coming. So that oscillation here you can see the oscillation. Okay, so that oscillation normally is coming due to the values of inductor. So this is called the ringing effect. So very less amount of inductor value means ringing effect will be more. Big amount of inductor value, that value will be less. But some other issues may be arise. Okay, so okay, another thing I have forgotten, that after the observation table, so you will plot one graph. Okay, in Excel file, your x-axis will be different values of R, y-axis will be what? Okay, y-axis will be voltage, current, and the efficiency. Okay, so variation with the resistive load resistance, what your performance, system performance is there, means voltage, how the voltage are changing. Okay, it is less voltage or same voltage, so you plot this one in Excel file in same graph, single graph. But what is the problem? You can see the compare the current waveform, current magnitude with your voltage magnitude. If you compare them, so load current value is more or less coming 1.5 ampere, but load voltage is coming near about 100 into root 2 times. Okay, more or less 100 into root 2 times. Okay, so like that it is coming. So if you making the range, there is some change, problem of the range problem. Okay, so it is higher value of voltage but lower amount of current, so current variation you cannot see prominently. So that's why what you can do, you can plot two separate diagram. Okay, one is for voltage. Okay, another voltage, and one is for voltage, another one is for current, another one is for efficiency. With the single diagram you can also see, but you have to amplify that value. Okay, amplify the current, scale down that current value. Okay, so that you need to do, but it will but if you make in different figure, different curve, it can take maximum 1 minute to plot all the curve in Excel. So you have taken 10 sample. If you take only 5 samples, so curve will not looking good. Okay, so there is a some differences in between that curve, different points are there. Okay, that's why you have to take at least 10 sample and 10 values of the resistance. Okay, so when you are changing the same study, you can do for RL load. So with the change of that inductor value. Okay, the entire rest of the thing will be the same. You just only change the inductor value. Okay, and for that inductor is very much responsible for your current waveform. There is it having some effect on the current waveform also. So load voltage is there, it's your load current. So both the diagram in that table, voltage as well as current, both the diagram you have to put. So rest of the thing will be same. Serial number, variation of the inductor. Okay, then input power, and then what is your output voltage, output current, output voltage, then actual output voltage from the calculations. Okay, then output voltage means measure output voltage, then voltage waveform. Okay, output voltage waveform, then current. Okay, so what is your actual current? Okay, then measured current from the ammeter, you are getting the measured current, then the current waveform. After that, the error current, you can take only one current also, load current, no problem. You can into money, load current is sufficient. Okay, load current, no need to do the calculations of load current, only measured load current is sufficient. current wavefront. After that, the power output. Okay, so power output, then efficiency. Okay, then how much error is there from voltage error, output voltage error. Okay, calculate reference value as well as the calculated value as well as the actual value. So less error means your system behaves perfectly fine. Okay, and you know that current, voltage, and that efficiency. That same simple thing, you have to put the same table. Okay, so 10 sample you need to take. So here we are taking that how much inductor value. We are taking that 0.5 Henry. Okay, so you can take another 5 sample like 0.1, 0.0, 0.05, sorry, point 1, sorry, that 0.5 is there, that 0.1, then 0.0, 0.01, 0.001. Okay, like that, and above portion you can take up to 5 Henry, 0.5, then 1. 10, okay, 15 Henry you have to take. Okay, so total 10 sample is required. Okay, so changing of the inductor value, what will be the voltage, output voltage is changing, actual output voltage, calculated output voltage, and measured output voltage. So how they are changing, that is figure 1, curve 1. Okay, same curve, then current, and finally efficiency. So three curves will be the same curve is also possible, or three distinct curve also possible after the observation table. So this is for RL load. Then RLE load. So here you can see that E means back EMF. Okay, so you know I think all of you are aware about it. So back EMF is there. So here we are considering that back EMF is very less. Okay. So how much value is it? It is taking just 0.5. Okay. So just for a moment. So 1 volt is taken. Okay, so your input voltage is more or less 100 volt RMS, and we are considering only 1 volt. So when we are checking it, it's not significantly changed. Okay, that value here. 1 volt is comparatively very less with your 100. Okay, so that's why what happened, you not properly understand. So in this study, what you need to do, so changing of that back EMF, 10 sample you can take. Okay, and what will be your waveform? So three observation tables. So first observation table by variation of the R, second observation table by the variation of inductor, and third observation table. You can do two things, variation of E and variation of L. Two things possible. Okay, whatever, if you want to show that variation, only variation of E, that also possible, and two things you can also do, but based upon you. Okay, and again the plot will be there. Okay, curve will be there, and if you connect the freewheeling diode, any of them, so that negative components is coming, that inductor voltage, the negative one maybe gun, negative portions maybe gun. Okay, so here you can see for RLE load, that one RLE load with freewheeling diode, if we see the waveform, so negative portion, that you can see the negative portion is there, that may be removed. Okay, so that one diode is there. Okay, one diode is connected. Here you can see that negative portion has removed here. Okay, the negative portion is not there. Okay, so simple thing, nothing complicated, and current waveform also be there for RL load and RLE load, voltage waveform as well as current waveform also important. R load only voltage waveform sufficient. So you can also put the current waveform, nothing problematic. So these all components you have to show in your report. Okay, after completions of those things, so you put conclusions. So segment wise conclusions, what what kinds of conclusion you can see with the variations of the load parameters, suppose R, L. Okay, then E, what kind of conclusion you will get from here, you please write over here. Okay, so for the reference, you follow any of the books. So Rashid book is good, Nedmohan, Erickson, whatever book you are following, so you can follow it. Okay, so there is no problem on it. So I'll share the materials for your reference. Okay, so you will get the help from it. So what are the parameter value, how the waveform will be coming. Okay, and your content should be quite enriched. Okay, so next class, what I need to see, I will check it, and I randomly ask your roll number. Okay, so I'll check your report as well as sometimes simulation, how to get this one. Okay, so by this way we can evaluate. After that, next class the Viva will be there as well as MCQ. Every day MCQ test will be there. Today also one small MCQ test is there. After that, today is no Viva, but experiment number 2, the next class maybe the experiment number 2 or the simulation experiment number 2. That class of Viva also be conducted with your MCQ test. Okay. So any queries from your end, Pratik?
Yes, sir. In the observation table, we have to means uh, uh, show the waveforms of all the parameters like 10 samples.
Yes, yes, small diagram. Okay, not big one. Okay, one small diagram. Crop the figure. Okay, copy the figure from before observation table. Some standard diagram will be there, like this manual. I provide you the manual. Like this manual, you will provide some reference diagram. But when you are putting the diagram in the observation table, so first copy the figure and paste it in the paint. So then crop the diagram. Okay, then make it then paste it in the inside of the table and make it small, only just for visual understanding. Okay, the axis is not important, but we need to see, basically I want to see that how the voltages are changing. Okay, both are same, that you can also understand. Okay, voltages are change, how the current patterns are changing, that is quite interesting. You will do the you will do the simulations, you can easily understand if you prepare all the thing in the same table. So visual differences you can understand, that is quite interesting. That is our main motivations of this simulation study.
Yes, sir. And for power, only the value we have to mention.
Power you can calculate, there is a measurement block is there. Okay, you can easily calculate that IRMS VRMS multiplied with that, you can easily get it. Okay, that power input side, output side power is very simple. So but in case of inductive load, how much the angle will be there, that is quite you have to think about it. Otherwise for resistive load, multiplication of the current you can easily get it. Or for inductive load, you have to get that how much phase angle, that is another issue that you can check. Basically it's a DC. Okay, average one is your DC directly phase. There is no problem of your output side. So direct multiplication is sufficient, I think so.
Okay, sir.
And then efficiency you can calculate. It's simple, nothing complicated. Basically, those are DC output side. So power calculation is quite simple. For AC side, it is quite difficult, but you can take it, consider it maybe the same phase. Okay. And you are end of the day, you are measuring that RMS value.
Okay, sir.
Okay. So any other queries from your end? Dhiraj?
Yes, sir.
So any query from your end?
No, sir.
No. Okay. Shivashish?
Yes, sir.
Any query?
No, sir.
Okay, I'll share you the link. So for your reference, to cross check it. Actually, there are 3-4 links I have. Okay, I have 3-4 links. I'll share all of them. You please cross check it where I was discussed. Okay, in last class, in your other section, I have also discussed in this regard. So I'll share their recorded version also. You will get some reference from there. And last year I will perform it. Last year I have some record the session, some of that simulation. So from where you can also get the simulation, how do you simulate it, you will get it also. But that manual is sufficient enough. So anybody can do it, nothing complicated one. Okay. Swagat. Swagat Kumar. Swagat.
Sir.
Hello.
Yes, sir.
Swagat Kumar.
Yes, sir. Yes.
Do you able to understand? Any query from your end?
No, sir. No, sir.
No, sir. Okay, good. Kanchon, Shantanu.
Yes, sir.
Shantanu. Okay, any doubt from your end?
No, sir.
Arya.
Yes, sir.
Any doubt from your end?
No, sir.
Okay. Annie?
No doubt, sir.
Okay, thank you. So, okay. So then I am just, please cross check your chat box. I am just sharing this material. Okay. And do you receive the material?